So today we're going to talk about something very important just to illustrate to you how this is going to change your life. And it's a problem that actually a lot of people are not aware of. I like to bring awareness to the class. And we're going to use math to help us out. So I'm going to draw you a nice picture and try to motivate what we're doing today. Yes, those are mountains. And over here, it comes down to a nice shoreline. There's water. Okay? And in this water, lives the Lake Washington lake whale. Have you heard of it? It's an endangered species, very hard to find. And our objective is to see, to try to save these things. You know, because here's what happens. You know what the U.S. Navy does? I don't know if you've seen this on the news about every few months. Fourth, fifth page below the fold where you can't find it. Navy vessels go out from Bremerton, you know, these submarines, and they got the powerful sonars, and they blow up whales out in the water, right? Because the sonar is basically going through them, and it's like if I were to take an ultrasound on you and crank it up and then put it right here, you'd poof, blow something up inside. And that's what happens to the whales. Okay? So this is why these are endangered. They're in Lake Washington. I'm not sure if there's submarines there, but there are. Navy runs exercises there. And we'd like to identify where they are. So here's what we're going to do. We're going to set this up as sort of a radar problem. I could have drawn a plane. That's what I draw in the notes, but we're going to make it more relevant. Here's what I want to do. Here's the idea behind sonar and behind radar in some sense. We're going to get a little lecture on this. So what I'm going to do is I'm going to have, I'm a scientist over here on the shore, and I got this device that I'll attach to a fishing pole. And down here. And then what I'm going to do with this, it's both a sender and a receiver. And what I'm going to do is I'm going to send out stuff at frequency omega naught. And it's going everywhere. And what I'm going to look for is stuff that bounces back, right? So the idea behind radar, sonar, any of this stuff is that it's going to come over here, hit this whale, and bounce back in all kinds of directions. Okay? And so what's going to come back towards this detector is some field at omega naught. And so I look, send it out, send my signal out, wait till it comes back. The time I send out to the time I receive, I can kind of get a distance estimate, so forth. There's a lot of signal processing that goes on here. We're going to just talk about very rudimentary parts of this. But the idea is I know my signal, I'm sending it out, and I know it's coming back. Okay. So this allows me maybe to do some detection. All right. So I could do the same thing, by the way, if I did do the airplane example. You know, there's radars that are up here, and then I got this super fast jet. And I hope you all appreciate that awesome little stick drawing I have of super fast jet in my notes. Okay? Same thing happens here. I send out a signal at some frequency, and it bounces back. Okay, so here's the idea. Suppose you're in that jet, and you don't want people to know you're there. I don't know why you'd want that. Maybe you want to be stealthy, and then maybe you call a plane something like a stealth plane or something. So the whole point is, you don't want this thing to receive that signal back. So you might make your airplane out of a special material that will absorb omega naughts. Nothing bounces back. There's nothing there, right? All right, so things like that. Or you might try to just figure out how can I just reduce the scatter as much as possible. So you might design your jet so that that would not happen. Or alternatively, you can fly one of these big planes up here. Have you seen these? AWACS planes. You guys know these? Did you guys read these? When I was a little boy, I loved airplane books. And I didn't like that jet so much because it looks dumb. This one I like. That one is dumb. But what this does, you know what this does? How about if I just blast the entire space here with omega naught? And then this guy's going to go, okay, I know this thing here is flying like way up here, but I can't see this anymore because I just drowned out the signal. Okay? All right? So these are kind of things you think about in radar detection. How to detect, how to not be detected, okay? And so it's a signal processing problem. And in particular, for many of these applications, if I want a good, clean detection, I'm trying to send out a signal and bring stuff back. But here's part of the problem. Careless people. Look at these people here texting. They're sending out all kinds of frequencies, polluting the airwaves. If you could see beyond your little limited view of the electromagnetic spectrum, you'd see pollution everywhere. Because we have cell phone signals, we have Wi-Fi, we have satellite dish networks dropping things down. We have a lot of noise in this thing, right? So if you were to look at the electromagnetic spectrum, there's stuff everywhere. Okay? So it makes it very noisy to be detecting this stuff. Okay? So part of what we want to understand is how do I extract out this noise, right? I mean, I'm going to blast it with noise, and I got to take this noise away somehow. But the one thing I do know is I am looking for a very specific frequency. If I just simply take a measurement here of, say, what's out there, I'm going to get these people's little tweets. Okay? Anybody tweet? Don't raise your hand if you do, because I'm just going to ask. Anybody tweet? Because I'm going to totally make fun of you if you do. Okay? So whenever I ask, do you tweet, just say no, because otherwise I will bring you up front, maybe even make fun of you. Okay? LOL. Okay. All right. So so anyway, you do this, and you have all this spectrum. What we want to do is, this is the problem we kind of want to look at today. All right? Does everybody feel super motivated? Yeah, like we're going to save the world in Lake Wales. All at the same time. I told you it's going to change your life, this class, right? Just in case you didn't believe me, and this is only day 2. Just think, you know? Day 30 will be like saving the universe, not just this Earth. Okay, so what I want to do is now pull up MATLAB, and we're going to start playing around with this idea of how to think about signals, how to filter them, and that is one of the standard things you do in signal processing. So a lot of this, again, falls under the aegis of what we call data analysis. You have signal, you have data. If you want to think about it this way, remember, I'm going to give, in all these contexts, I'm going to give you an example. Like this is an example that comes out of sonar or radar. But you should never think of it as sonar or radar. You just think of it as, this is a data analysis problem. I am trying to extract the real data I want out of noisy data. Okay? Your application may be very different. Never confuse it that this is really about radars. It's never about radars, or it's never about specifics of that sort. We're going to do a lot of image processing in the class. This is not an image processing class. It's really easy to illustrate the ideas within image processing because I can just show you. But this is just data, and you can take these techniques and apply them to anything. Okay? So I want you to have that in your mind as we move through the quarter.